So this is actually technically 4-2 day 2. Those that are home, all right, great. This thing just so frustrating. It just locks up when it blah blah blah. Who cares? But it's 4-2 day 1. Not going to do a 4-2 book assignment. We don't have a book, Mr. Samuels. I know. But on Monday we'll probably hit these again, in a more complicated fashion. So today we're just doing a simple delta math, and it probably is a little too simple, but that's fine. We'll get the first two rules here. Actually, I should have waited on this quotient rule, but it's fine. And I like doing this, the whole double look here from pointing at the screen. But the first one, I implied that you knew this. Like, when we had this question, hey, what's the fourth root of m to the eighth? Well, I didn't want to write 8m's, but I wanted you to imagine that there was 8m's. And I'm standing in front of this on purpose, so you listen. Because a lot of times, here's the problem. Students become robotic. I love those shoes, though. Lockport, right? Nice. I got my Lockport shoes on. See them? Anyway, so it's not about memorizing the rule. It's about knowing what's going on here. So I wanted you to visualize that this is 8m's multiplied across. And a fourth root wants four things multiplied together to be pulled out. That's the whole idea. So then yesterday I implied that you knew this exponent rule. M to the eighth is m to the fourth times m to the fourth. You would add these exponents. All right, and that's how that's working backwards. But then, now I could simplify this and get m times m, which is m squared pulled out. So I implied that you knew this rule already, is what I was getting at here. So now there's the rule off to the right. Numbers of the same base multiplied together, you add the exponents. Don't be a robot. Understand why. And then it's not memorization. It's not flip of a coin. Which rule do I use? Do I add them or do I multiply them? That's not the thought process that should be going on. Think that 8 to the third or 8 to the second is 8 and 8. Think that 8 to the third is 8 times 8 times 8. How many 8s do I have multiplied together? 5. That's the rule. That is why. Once you know the why, it's not a, what's the rule? What do I do? Kind of thing. And then I really broke this down, and I actually broke this down later, but the quotient rule actually creates two more rules. And actually one of them is the negative exponent rule. But really what I want you to, think about is x to the fourth over x squared. Where are there more x's, top or bottom? 3, 2, 1, go. Answer. Top. Not many people were ready for that, weren't ready to answer my question. Y to the third over y to the sixth. Where are there more y's, top or bottom? 3, 2, 1, go. So everyone should be able to do this. Everyone should know that this is y over y. And then 3 of the y's cancel. There's 3 y's left over on the bottom, multiplied together, which means y to the third. But then if I do the subtraction rule, this occurs. If I do 3 minus 6, I get y to the negative third. That is why the quotient rule, the rule, creates negative exponents. So what's going on here? These are, and then look at what the thing does. I just love this program. It's so fun to deal with. These two are equal. So therefore, I'm going to reveal this, and I wish my notes were more like this. This creates the negative exponent rule. Right? And that's why I tied these. The quotient rule actually creates the negative exponent rule. And actually, I wrote this down again. So I wrote in the middle, x to the third over x to the sixth. We can approach this two different ways. It's the same exact thing I have up there. Xxx over 6x's, 3 of them cancel. So if I did this through just knowledge, through just this is what happens, I get 1 over x to the third. If I do the subtraction rule, numerator minus denominator, I get x to the negative third. Oh, well, these two must be equal, and they are. And that's why the negative exponent rule exists. Okay, and then in the middle, I guess I'll reveal all these with the little examples to the right. And now I keep this in column format, and I'll leave these here. Go back up to the power raised, two numbers of the same base multiplied together. You add the exponents. Oh, okay. Well, this one's not as easy to conceptualize. So this one we have to employ the rule. 4 to this power times 4 to that power, you add the exponents. Good thing they already have a common denominator. That becomes 4 to the 1/3. All right, and then this one, the quotient rule. Actually, too easy. You might have 3 to a fraction over 3 to a fraction. You'd subtract the fractions. So now sometimes it is the rule, but understanding what's behind the rule is the key. All right, then sticking these two in the middle before I get to the negative exponent rule yet again, created by the quotient rule. If you have a power raised to a power, you multiply these exponents. That's where people flip coins. They flip coins between these two rules. Hey, when you flip a coin, how many times are you right? 50%, which is a what grade? F. Okay, that's my point. You want to understand where these are coming from, not flip coins. These are the two most misconstrued between the two things, product of powers and power of a power. So it's smart to figure out that, hey, oh, this means I have 5/8 multiplied together. So that's the add thing. This one right here, 2 to the second raised to the third, that's 2 to the second times 2 to the second times 2 to the second. Each 2 to the second is 2 2's. So I have 6 2's multiplied together. So knowing the basis of an exponent, these rules, are common sense. I hate to say that, but they really are. And then this one, power of a product, you distribute that power. It just means that both are raised to that power. Now today, this is what's going to happen to you fractionally. 16 to the 1/2 is not 8. It's actually the square root of 16. That's why there's a 4 there. Did someone do that last hour? They took and multiplied those two. Nope. You didn't memorize what an exponent as a fraction means. And then the next one, power of a product, knowing that if I have 7 to the third raised to the 2/3, you multiply these and these 3's cancel. This becomes 7 squared as a work off to the side. So, okay, we can make sense out of the rules, but then when we get those fractional exponents, we really need to know the rule, right? Because it's not really easy to conceptualize. Hey, remember I did that to you yesterday? I said, oh, you know what? I put some negative exponent questions in, right? But now let's look. I actually explained it, so I don't want to over-explain it here. But I did want to explain the zero exponent rule, the last one that I show you here. And a real simple example to describe the zero exponent rule is just x to the third over x to the third. First of all, something over itself is 1. Everyone should know that. Everyone should know that this comes out to be 1. All right, something divided by itself. But if I employ the subtraction rule of exponents, I get x to the 3 minus 3, which is x to the 0. What's going on here? Oh, what's going on here is because of that subtraction rule, it makes something that is equal to 1. So therefore, anything to the 0 power equals 1. I don't know what to tell you. That's where it comes from. And this is the why. When you understand the why, memorization is no longer needed. You got it solidified. And those that really are in tune with the notes and pick up things quick should appreciate those whys, because then it gives you a much better chance of moving on and memorizing more complicated things. Anything to the 0 power is 1, right? Doesn't matter what it is. Okay? All right, let me freeze that for a second, as I didn't show those examples to the right too quick. Those online, don't watch what I'm doing. Those on the YouTube video. All right, and then just 4 simple examples. Hopefully I didn't start too late here. Okay, ready? Did I reveal the examples? I see a couple more people writing, and that's your right for sure. All right, so I get ready with these 2 next ones. Good to go? I like all that stuff that I have there that explains the stuff. Again, tripling down on don't memorize a rule, know why the rule happens. And then you're going to be awesome. Okay. Oh, yeah. All right, let's get this going here, Mr. Samuelis. Okay, notice what this says. Rewrite the expression using properties of exponents. This is where this gets a little crazy. Um, and this is why the CAT students like freaked out when I did all the exponent things in one day. What we're doing in probably 3 days or 4. A little overloaded for that. They weren't very good at it. I guess I understand that now. But when you're dealing with fractional exponents and they want you to simplify it or rewrite it, and it really is a simplify, your answer should be in fractional exponents. On Monday, everything's going to be presented as a square root question. Your final answer will be a square root question. That's where this gets a little, crazy. What do I do? Do I turn it into a radical after I'm done? No, leave it. Okay, but the delta math is kind of easy on this, but there are a couple fractional exponent questions. You don't take 8 and multiply it by 8 and get 64. The rule is 8 to this power times 8 to that power. You add these exponents. And now if this was a quiz question, okay, I know I have to add these. Then as a quiz person, I would go back and get a common denominator. Since I have to add the exponents and they're fractional, now I go to my grade school. How do I add fractions? Common denominator. Then this is negative 2 over 6. So this is actually equal 8 to the 3/6, which is actually 8 to the 1/2. Now this is what I mean. What do I do next, Mr. Samuelis? Do I change 8 to the 1/2 to a square root and then start simplifying that square root? No. When it starts as a fractional exponent, put your answer in simplified fractional exponent form. Someone could say something here, though. There's another alternative answer for this. What is 8? I'm asking, how could I rewrite 8 as a power, like something raised to a power? Anyone want to raise? Good, go ahead. There we go. So you could, if this was a written exam, do this. 2 to the 3rd raised to the half, which is 2 to the 3/2. I didn't do that last hour. I just thought about that. That is also another optional thing you can do. But you don't have to. Certainly the first answer, I'm not even going to tell second or first hour about this alternative answer for this one. Because what's interesting is if it would have, well, it would have shown itself in 8 anyway, so never mind. I'm not going to say what I was going to say there. All right, so hopefully you understand that. That is a possibility. We're actually going to do something like this later where it does simplify. So, all right, next thing, power raised to a power rule, and it also works with a fraction. I'm not sure I had a fraction raised to a power rule up there. But it's just like a product rule. If I have a fraction raised to a power, the whole thing, you can raise the numerator and denominator as well. So what this becomes, I know what some of you might be thinking here. You could have done this before what I'm going to do next. Okay, fine, I'll write this because I have a lot to do with y anyway. 3 times the 2/3, if you didn't understand how those 3's canceled. Over, and then this is x to the half times 2/3. That's what the rule is. You multiply those exponents. All right, I do have a couple more things to do. This is x to the 2/3 times y. The 3's cancel. Oh, nice. Y squared, no fractional exponent. And then down at the bottom, the 2's cancel. Please keep track of your numerator and denominator. This is x to the 1/3, not x to the 3rd. A lot of people try to say 3's on the top now. And then this is not a final answer because I have these. Okay, fine, I lied to you. All right, but just remember, when it's this over this, it's the subtraction rule. And I do want to subtract numerator minus denominator. All right, this simplifies these. So this becomes x to the 2/3 minus 1/3 times y squared. And it does end up on the numerator because you went numerator minus denominator. And then last hour I did do this. Fine. I mean, please don't be robots when you have questions like this. But you could, first of all, where are there more x's right here, top or bottom? Say it again. Bottom. So you could do 6 minus 3, but then the answer is on the bottom. And that's the thing I want you to think about. I don't want you to be robots. I want you to know that this should be 1 over some x because there's more x's on the bottom. So if you do 6 minus 3, then the answer belongs on the bottom. All right. But really, I hope you have this in your head. I really hope every time you do questions like this, you have that in your head. This is the why. All right. And then knowing the why, then you'll know that this is what I got to do in that yellow. All right. But anyway, the final answer is 2/3 minus 1/3 is 1/3. So it's x to the 1/3. Some people get all happy that they've done their, fraction work, and then they just write 1/3 as an answer. They forget it. It's x to the 1/3. Right? So just be careful there. All right. I try, you try. I like this one because it incorporates what we had a little bit yesterday. Okay, so again, it's a power, a fraction raised to a power. So we're going to have this. And then we are going to have this, and I, as a note person, I'll write this out. But hopefully you don't have to write this out. You'll know that the 2's cancel. All right, and then we're going to do what Aiden had said. We're not going to change this to a 5th root. We're going to change 32. All right, we're going to keep this fractional exponent thing alive. No one really answered this last hour. What's 32? What number to what power? 3, 2, 1, go. 2 to the 5th. And that's what we can do. And it does the same thing as if I would have changed that into a 5th root. So what I'm going to say next is the 5th root of 32 is 2. All right, but then when I change this to 2 to the 5th raised to the 1/5, well, then it becomes 2 to the 1st, which is just 2. So yes, the 5th root of 32 is 2, but then here it shows itself in the exponent rules. And I kind of like that. 3 to the 1/2 is just the square root of 3. So that's it. You just leave this. And no, nothing can happen between these two. You can't subtract exponents because these are not the same number. It's only same number divided by same number, or same variable divided by same variable. You subtract the exponents. So that actually, interestingly enough, is the final answer. Okay, and then last but not least, just keep your simple order of operations done with these fractional exponents. And I can argue that this is exponents that can actually be done, or parentheses if you want. Hey, I got to clear these parentheses by getting this exponent taken care of. So taking care of that exponent means I distribute that power. Let's try to go right down here on all these. Times a to the 2/3. And then just for no purposes, know when I multiply these two, the 2's cancel. In this high level honors math class, we should be able to handle that. 2/3 times 1/2, the 2's cancel. That's how I get b to the 1/3. And then knowing that the rule is for this, adding the exponents, 2 times a to the, I'm going to actually go back up to this question. Since I have to add these exponents, I got to get a common denominator. And that's what I'm going to accomplish by doing that. So rule, a times a, add the exponents, go to grade school. Add those by getting a common denominator. 3 plus 4 is 7/6. And then this is what I mean about, this is where this gets a little crazy. If anyone thinks about turning this into a radical, there would be something that would come out. Like there would be something that would simplify. When you start with fractional exponents, write it as a fractional exponent at the end. All right, and that's where that gets a little rough. That's why these are good questions for multiple choice. They really direct where your thoughts are and how this is supposed to happen. Okay, all right, good to go.